Okay, we're back. This is the first of two examples that will work that looks at finding the optimal weights or an optimal portfolio made up of two risky assets without perfect negative correlation. All right. So in the previous video, we derived the optimal weights, what the optimal weights will look like. We're going to assume we have two risky assets. One is asset D, one is asset E. Asset D is the less risky of the two assets. How do we determine which is the less risky of the two assets? We're just going to look. We're going to calculate the variance of both assets, and the variance with the lower, or the asset with the lower variance, is going to be asset D. Okay. So we have this formula, and then we have the optimal weight for the riskier asset. So suppose you currently own an index fund that tracks the S&P 500. We'll call that asset A. You're looking to diversify and invest in a biotech fund, which we will call asset B. You've taken the means and the variances of both assets. Additionally, you've calculated the covariance between the assets. Below is a table with the information. Okay, so we've got a mean of 12.5%, which will approximate with the expected return. We've got the variance of 0.09. Okay, this is for asset A. For asset B, we got a mean of 0.142 or 14.2% and a variance of 0.16. All right, so we can determine which of these two assets is going to be asset D, or the less risky asset. It's going to be the index fund. All right, we've also calculated the covariance of these two assets here in this column. So what I'm going to do, I'm just going to use Excel. So you have this here. I've got the means of the two assets, the variances of the two assets, and the covariance of the two assets. So what I'm going to do is I'm going to find the optimal weight of D, okay, and I'm going to use this formula to do so. You're going to have to be a little bit careful here, okay. So I'm going to take the expected return of D, which is the mean of the less risky asset, which is 12.5%. I'm going to times that by the variance of the riskier asset, which is asset B. I'm going to subtract the mean of the riskier asset, and I'm going to multiply that by the covariance. Okay, so that's the numerator. All right, I'm going to divide this by the mean of the less risky asset times the variance of the riskier asset plus the mean of the riskier asset times the variance of the less risky asset I'm then going to subtract out the sum of the means of the two assets I'm going to multiply that by the covariance. Okay, let me double check my work. I've got the mean of the less risky asset times the variance of the riskier asset minus the mean of the more risky asset times the covariance. And in the denominator, I've got the mean of the less risky asset times the variance of the riskier asset plus the mean of the more risky asset times the variance of the less risky asset minus the sum of the means times the covariance. It looks like I've got it. Okay. And so I get a weight of 0.6071. Okay. The optimal weight of E is just going to be equal to 1 minus that. Okay. And this gives us the weights that we should put in or keep in our index fund versus the weight that we should put in the biotech fund. Okay, so hopefully this example has shown you how applicable What we're doing here is finding the optimal portfolio for two risky assets without perfect negative correlation.